All right, class, good morning. Today we're going to be starting Chapter 11. When you first see this posted, you'll see the PowerPoint posted with just the first three sections, so 11.1 through 11.3. I'm finishing up 11.4 and 11.5, hopefully in the next couple days. So without further ado, logic. Now, one thing that's really nice about this logic section is you do not need a calculator. A calculator will serve you no purpose. It will be incredibly unnecessary, right? There's no way to use a calculator with logic, so that's something to keep in mind. So let's do a brief introduction. So logic and the idea of logical argument was introduced by Aristotle a long time ago. He lived between 384 and 322 before the Common Era. And what logic was is it was appealed to people's logos. And logos is a Greek word that means word or reason or plan, okay? It's a foundation not only for coherent arguments. Maybe you've taken a speech class or a discussion class or had to write an argumentative paper, but it's also incredibly useful in mathematics and especially computer science. And I know a lot of you guys are really interested in computer science. Logic is incredibly crucial in computer programming. So what we're going to cover in this first section are statements and truth values, what compound statements are, how we can use variables to represent statements, and some logical connectives. So first off, a statement is a declarative sentence that is either true or false. Those are our only two options, okay? So for example, Abraham Lincoln was the 16th president of the United States. That is a true statement. The Blues won the Super Bowl. That's not a true statement because the Blues are a hockey team. Okay, they would have won the Stanley Cup, which they did. It's important to know that no statement is both true and false. Okay, and there are some non-statements. Non-statements don't have a true or false value. So, for example, they could be something like an opinion, like he's a really nice guy, or something like an order, get your feet off the table, or a question. Right? A question doesn't have a true or false value. The answer to that question could be true or false. Is today Wednesday? That's actually false. It's Thursday when I'm recording this. But the statement is today Wednesday. It doesn't have a true or false value. The truth value of a statement is either true or false. Okay? Statements are either true or false. Okay? They're never both. And we may not have enough information to know the truth value, and that's okay, right? We could say there are 10 to the 25 atoms in the universe. Is that true? I don't know. We don't know if it's true or false. So that's something to keep in mind. So let's look at a couple more examples of statements. So George Washington was the first president of the United States. Is this a statement? Yes. What's its truth value? Well, its truth value is true. This is a true statement. The New York Knicks won the NBA basketball championship in 1989. Okay, so this is definitely a statement, but is it true or false? We may have to do some research. If any of you knew the answer to this, kudos. I had to Google it. This is actually false. And last, the number of atoms in the universe is 10 to the 75th. This is a statement, like I said earlier, but we don't know if it's true or false. We can combine two statements and form a compound statement using and, or, not, and if then. A simple statement is a statement that is not a compound statement. So for example, here's a compound statement. The number 5 is prime and the number 8 is even. The simple statements are the number 5 is prime and the number 8 is even. And is what we used to join the two. The next statement is if Missouri is in the Midwest, then tomatoes are a fruit. So we can break this down into two simple statements. I have Missouri is in the Midwest, tomatoes are a fruit, and for this one I used if then to combine my statements. Okay? First off, I never said that compound statements needed to make sense or be completely true or false. So that's something to keep in mind. It doesn't have to be true to be correct in logical sense. So one thing we need to do in order to develop rules for logic is we need to be able to work with logical statements, not specific examples. So we can denote our simple statements with variables. We tend to use P, Q, and R. So let's let P stand for the number 5 is true. P has a truth value, right, because 5 is prime. And we can let R be, I like how I said the Washington, D.C. Okay, Washington, D.C. is a state. So R has a false truth value. Washington, D.C. is not a state, but the Senate is trying, in case you didn't know. All right, so we can use logical connectives, the symbols for them, to combine our simple statements, okay? So when we're writing our compound statements in terms of their component parts, so their variables, we're going to use the following symbol. So I use this upside down V for and. We call that a conjunction because we're joining things together. We use an upside down V or caret for or, right? We call it a disjunction. Negation, we use this tilde sign for not. And implication, that's when we say if then and we use a forward arrow. So let's write our compound statements using symbols for our connections. So just keep in mind that in logic, we will manipulate our compound statements in order to find expressions that are true, no matter what we were given as variables. So let's take a look at these examples. Let P equal Fred likes Cindy, and R equals Cindy likes Fred. If I have Fred and Cindy like each other, that's going to be P and R. If I say that Fred and Cindy dislike each other, that's going to be not P and not R. This is supposed to be Fred. I don't know where Steve came from. So let's say I have P disjunction R. That's this right here. That's Fred likes Cindy or Cindy likes Fred. If I have P disjunction not R, I have Fred likes Cindy or Cindy dislikes Fred. That's how I could write this out in words.